Hi. So my name is Rodrigo Sarmiento. I am a co-founder and chief data scientist at Descifra. Descifra is a Mexican company. We founded 5 years ago to create data products based on geography. I know it's been a long day. There have been a lot of talks. So I'm going to just quickly go through 5 use cases we've come up. And let's hope we all get through it. So just to make sure you understand, what we do is develop technology solutions on top of CARTO, which is what brings us here. And we build predictive and machine learning solutions and modeling on top of that. So what we do is go through this process we develop this methodology, which is from asking the right questions to all the way to doing a data product and solving the questions to that. So I always go slowly with this because whenever we're invited to forums of machine learning and such, everybody's in a rush just to build a neural network and start doing stuff. But it turns out in our experience that most of the challenges we had solved have been solved because we go very thoroughly through all these steps. So I'm going to just go through them, which is getting the right questions. It's always like sitting down with the people who's going to need to use the information and understanding very carefully what they expect the answer to be. Then defining geography and the boundaries of where do you want to solve that. We always put Mexico there because we're Mexican. And there's later a step of binding all the data. Like everybody is opening APIs and drawing lots of sources, but there's not enough effort in stressing the importance of getting the areas right. And this is very important because people don't always realize that you can make pears be friends with apples just because they're right next to each other. So this is very important. On the next step, you would, which is the bottom step with the small map, what you'll be doing is defining metrics or variables as features of the things you already collected. So a good example here is everybody just can get data on points of interest, on where are households or where are businesses located, but that doesn't make any sense for a business user. So what we do is, for example, create an indicator of the balance of households to businesses to make sure to know if an area has movement during the morning time or during the evening, or if it's only workers going there, et cetera, right? And then once you went through all these steps, then you can think about doing all the big data machine learning stuff, on which I don't know, I wouldn't want to go into the math stuff, but basically you can literally run tens of thousands of models, and a lot of people are writing about that. But our take is that for geographic problems, most of the models have to be random forest models. And in the end, you put that in a platform. Because it doesn't matter if you created a deep learning recurring neural network or a regression. If you cannot put it in a place where the user can actually make that become a business strategy or a business action, that is not going to make sense. And the last thing is, once you do that, you don't want to go and just diagnose the patient with a condition and then send him home. You want to make sure that he's administering the medicine and he's getting better. So the other thing is, we don't just make models and throw them, because once you throw them and people take actions based on your model, the reality is going to change. So you want to make sure that you're taking into account the way reality is reacting to put it back into your model. So that being said, and this is what we do, I'm going to go just through quickly. I don't think we have a lot of time, but through 5 use cases we had with our customers using this methodology. This would be, yeah, so I'm just going to skip through it. So actionable answers is a case, our client didn't allow us to use their name, but it's a major European retailer for sporting goods that wanted to open in Mexico. And their question was as basic as, what cities in Mexico should I go and open in? And why, like inside a city, where's the place that retailers are located, and where should I be looking for a spot? So we just did 3 easy things, which is formulate a good question. They wanted to do like tons of different analytics, KPIs, and it was like, you actually don't need that. You just need basic stats on where the people live, where the people shop, and where the people work, and make sure you put it in a really nice map, and they have opened like 10 really successful stores because they have really nice thematic mapping. So, and they really do not like to hear that because they want to listen to the recurring neural network, but sometimes the answer is just as easy as doing that. A second case is a major bank in Mexico came to us, and they said, we have 2 months to open 300, 350 or something new ATMs, and we have really no idea like, where to start. And the solution, again, was not a very complex model, but it was just to classify the streets of the country. It's hard to point it both sides, but what you're looking here is like the vectors of the streets in Mexico. We just mapped where the other ATMs of the competitors were and made a list of the top 500 streets with a lot of like banking business in which they weren't there. And that's it. Then you solve a really complicated problem with an Excel sheet of you should go and look for the streets, right? And like our takeaways for that is look for new data when you're not sure, because we didn't even know in Mexico there was an indicator for how many money were ATMs making, like by each ATM, and we found that. We aggregated them. We aggregated it wisely, and we kept it simple. Again, it's just a list of streets listed by amount of business, and in that way they can solve a $1 million problem. Another problem we have solved is a company came to us, and they had a gym. And they said there were 2 partners. One of the partners was claiming that they should go and put billboards on all the city, and the other one was claiming that it didn't matter because all the customers were coming from very close places. So we used their app to track these customers, and we basically came up with a way of knowing where these people lived and where these people worked, and that made the argument for the guy in favor of the billboards, so that they could, like, he got the amount of money authorized by the other partners because he had the data to prove they needed billboards all over the city, right? So, like, again, like what we learned from this experience is always use the best granularity you have for maps because it's you can improve the decisions you make by using those new insights of granular data. The other one is predict what is missing. What I failed to mention before is we knew where these people lived and worked, but we didn't know what streets they took to get to the gym. So we had to make predictions and infer what are the most important routes people were taking to place those billboards effectively. And the other one is, in this case, they didn't even want a platform. They just wanted to say, yes, that's a fact. People come from at least 3 miles away or 5 miles away, so we need to place billboards in main streets. This one is a little more complicated. We have a customer that has 3,000 stores in Mexico, and they wanted to open 2,000 new stores. So they have 100 people looking for new places all day, every day in the streets. And what we provided them with was a platform in which they could just for a middle manager to receive all the information of the 100 people on the streets going and looking for places. So they would go in their cell phone and input an address and say hey, I found this place, it looks amazing, I just spoke to the owner and such. And that would go through a machine learning model. It would predict the expected sales and then send it to a middle manager who could approve or not the project based on all the geographic data around this place. So that way they can open 2,000 stores, having it in a centralized way, and using a map and a CARTO map. I mean, it's just a really cool way of changing the way they are making decisions in the company. And the last one, so the key takeaways are select a practical model. I didn't actually know what to expect because sometimes a lot of data scientists show up and sometimes a lot of business people show up. So I try to do it more or less in a mixed way and then hope for the best in the question section. But in terms of machine learning, like do not go with a very complicated thing if you want it to work in real life. Like usually models that can be implemented very easily are the best option. The second one is to understand very well the needs of the guy who's going to use it. Because in the end, these guys are paying us because they can click one button and make sure the manager has all the information around him. And the other one is a reinforcement of the idea I was telling you at the beginning, which is you want to make sure that whenever they open a new store, the rest of the information and the people in the model are aware of that, because no longer the plan they had like devised before will be working effectively, right? And the last case is we helped a company that provides internet access decide how they wanted to place the new lines of optic fiber. So what we used was create a predictive model that takes into account the price that they pay to build a new line of optic fiber and to predict how many users in each block they would have. And then we ran it for the whole country and made a standardized way of ordering that. And it's a very complex thing because then they have like a whole team that makes sure that in the real world it's possible. Sometimes you say, oh, let's just go build it. Like the algorithm is saying, that's a great idea. And you go there and there's like a river that we didn't map, or somebody built, I mean, Mexico has really weird cases, but it could be the case that somebody just went and bought a whole lot of land and you cannot go through there. It could be the case. So on top of CARTO, we also built a way for them to make sure that people in the ground and the technical stuff can add the information of whether it's going to be feasible or not. And yeah, and that's basically it. So just, again, the thing is like understand very well the business. This was very complicated because the issue, they couldn't solve this problem before because they didn't have a way of communicating with the people in the ground and making sure that it was real. And then build a data pipeline on top of it. The next challenge was that their data sets were in a really complicated format. I mean, we've been in this industry like for years, and I haven't even heard about it before. And even though we had a really complex model to predict how many users would turn out and would actually like be willing to switch to that company, the results were very easy to read. Like the manager just got a letter saying, this is a great idea, and the return is going to be like $2 for each one you invest or something like that. And that's basically it. I just wanted to share some of the things we do. And if you have any questions, feel free to tell me. Thank you.